Well, this is going to be a video on fusion reactors, and this is the current design that a lot of private fusion reactor companies, I guess, are trying to use. I guess it's called a tokamak or a toroid. Anyway, they have the design where they have a plasma that goes around a donut-shaped toroid, and they have magnetic fields or superconductors around it like this in a circle, trying to keep the plasma going in a circle. But the problem with this design is that on the inner part of the toroid is where the magnetic field lines are most compressed, and on the edge, outer edge, is where it's least compressed. So there's more magnetic field strength on the inner side of the toroid than on the outer side. So I guess the plasma has a tendency to drift towards the outer wall. And the other design that they use, let's see, is it this right here? Well, it's something like this, where they have a small little bead of, I guess, hydrogen, and they shoot all kinds of really powerful lasers at it, and they try to make it fuse that way by shooting a bunch of energy into one point. But I think that these ideas are good attempts in creating fusion, but I don't think these are the right designs for the fusion reactor to actually work. Um, During my studies of electricity, I came across this apparatus, which uses Helmholtz coils. There's two coils that are one radius distance apart, and they're parallel to each other. And this vacuum bulb right here has a electron gun, a cathode and an anode. And what it does is it shoots electrons in a single direction, and when you activate the coils outside, it puts this very strong circular magnetic field on these electrons. So they have a tendency to curve back towards the source here. And what you can do is, if you turn up the power for the gun, for the electron gun, it makes the circle get bigger. But when you increase the electricity going in the magnetic fields of the Helmholtz coils, it makes the electron beam get smaller in radius size. So this design makes a little bit more sense than these ones over here, because there's no problem with the magnetic field being a different size. It's a uniform size in this design. These coils are putting the same amount of influence all around this beam of electrons, versus in this toroid, there's a difference in magnetic field strength. And this other one, where it shows all the lasers shooting at a single point like that, I'm surprised that didn't have more chances of succeeding. I don't know if they've done all the tests with that design yet or not. But if you have enough electrical power at your disposal to run something like this, you would think that you would try this kind of a design too, where you would put a lot of power into this beam of electrons, but at the same time you would put a lot of power into these coils as well. So the stronger this beam gets, the more power you put in these magnetic field coils to keep this circle from getting too big. What I would do is, if I had this apparatus, is I would use these magnetic field coils to shrink this circle down to the smallest point it could, where this beam is going in like a very tiny circle, like right here. Try to get this beam of electrons to be in a single point if I can, and then increase the power into the beam, at the same time increasing power of the coils to make sure the electrons stay in that one spot, and then at that point, you just crank the power up as much as you can, because this, you're keeping the electrons in a single point, and you're increasing the amount of electrons that are being put out by the gun by increasing the power of this electron gun. And if you increase the magnetic field of the coils in sync with increasing the power of the electron gun, then you should keep them all in this single point. And if you have like a hydrogen bead or whatever like this at that point where all the electrons are going, then what would happen? Is my question. Would that be enough to? Would you be able to put enough power into an apparatus like this to be able to achieve fusion versus the design that they're attempting over here? So I just thought I'd throw this idea out there for this coil design, because it has the electron beam gun that comes around, and there's got to be a way to make it so this beam of electrons runs into itself, because this looks like it's just gonna miss it where they're coming out. I'm not sure how this design works, if you can do that or not, but this apparatus would force the electrons to squeeze together by these Helmholtz coils, and the more electrons that you can squeeze into a single point, the more chances you have of creating enough pressure to fuse those electrons into something, like what happens when you compress. It's almost like you're trying to create your own little ball of lightning right here by compressing all this single beam of electrons into a single point, versus trying to make a beam of plasma as thin as you can in a toroid design, or use a ton of laser power to a single point with this laser guided hydrogen bead design, or whatever this design right here. But this design right here, I don't think I've ever seen attempted, and I'm just very curious what would happen if you had a bunch of power at your disposal to put into an electron gun like this, and at the same time keep that beam into as smallest point possible with these Helmholtz coils. And yeah, it'd be very interesting to see where that would lead in an experiment. Like, would it get so hot where the glass begin to melt, or would this gun with the anode or the cathode begin to melt? Like I'm sure heat would probably be some sort of an issue here with this design, but that doesn't mean that couldn't be fixed. You couldn't figure out a way around that by making the cathode and anode a superconductor like material, or what have you. You never know, because with superconductors you can make an apparatus like this not heat up at all, because there wouldn't be any resistance in those superconducting materials. There would be no resistance, there would be no way for it to heat up. So I just wanted to throw this idea out there for a possible design for a fusion reactor using Helmholtz coils and an electron gun or beam apparatus to use a magnetic field pressure to crush it into as smallest point possible, and at the same time increasing the power of the electron gun. And yeah, with an experiment like that, see where it leads to by constantly increasing the power, and see what happens, see what the results are. Okay, so thank you for watching, and have a good day.